The next technique that we will review for factoring is going to be factoring by grouping. This is very similar to factoring with the GCF method, except we're going to be doing groups of two. Typically speaking, for this factoring by grouping method to work, you gotta have problems with 4 terms or 6 terms or 8 terms. So the number of terms should be an even number of terms. So like for example, in the first one, we have AB minus 3b, so far that's 2 terms, negative 4a plus 12, that's 2 additional terms. So the total number of terms is 4. So this is an even number of terms. So that means we can try to use the factoring by grouping. Now keep in mind again, before you try to factor by grouping, you want to try the GCF method. So look for if all the terms in the problem have something in common, which they don't in this case. So what we do next is we break them up into groups of 2, and we look at what each group has in common. So for example, I can break down the terms as a times b minus 3 times b. I can also break down the 4a as 4 times a and the 12 as 4 times 3. And in this way, I can now clearly see that the first group has a b that's repeating, whereas the second group has a 4 that repeats. So those are known as the GCF of each group. So the first group, factor the b out, and you're left with a minus 3. The second group, we're going to factor the 4 out, and not only that, but also, since there's a minus on the first term, we're going to factor the minus as well. Now keep in mind, when you factor the minus sign out, your terms on the inside gets flip-flopped. So they get switched from plus to minus or minus to plus. So the positive that was there turns out to be a negative at the end, and then we put the 3. And if you're doing this correctly, you should notice that the terms a minus 3 and a minus 3 are going to repeat. And again, think of it like this. We have one giant box and we have another second giant box, and the a minus 3 is repeating in both of those boxes. So just like we did with the b at the start and like we did with the 4 at the start, we take the common thing that's repeating and we write it first. In this case, the common thing that's repeating is a minus 3, and we put the leftovers together in the second parentheses, in which case that will be b minus 4. So the a minus 3 goes first because it's the GCF of those two terms, and the b minus 4 goes after, and that's it. We are now completely done. Let's try it out again with x cubed minus 7x squared minus 4x plus 28. So I'm going to begin by writing down x 3 times, then the 7x squared, 7xx. We've got the 4x, I'm going to write it as 4 times x, and 28 can be written down as 4 times 7. Notice how the 4 terms have nothing in common. However, the first pair have some repeats, and the second pair have some repeats. So what are the repeats in the first pair? There's x repeating 1, and then a second time. So the x is repeating twice, so that's x squared. Leftovers are x minus 7. In the second pair, the 4 is repeating, and not only that, but also the first term has a minus sign. So we're going to factor a negative 4, and we're left with x and 7. Keep in mind that the plus sign is going to have to be switched to a minus because we factored a minus with the 4. So as you can see, inside my parentheses, there's x minus 7 on the first one, and there's also x minus 7 on the second one. So we're going to grab it and write it first. And again, we're thinking of this term, x squared times x minus 7, and then a negative 4x minus 7. Since they have x minus 7 repeating, we put it first, and the leftovers are x squared minus 4. Now keep in mind that x squared minus 4 is itself a pattern. It's got 2 terms, and they're perfectly squared. So the 4 is 2 squared, and the x squared is literally x to the power of 2. So that means we can break it down as x minus 2, and then x plus 2. So that last term, x squared minus 4, got broken down into these two, x minus 2, x plus 2, using the difference of squares formula. And that's the end of this particular problem. So pause the video here and see if you can do part 3 on your own, and I'll give you the answer in a couple of seconds here. So here is your chance to pause and try this one out. So this one was a little bit trickier, and here's what I did for this problem. And again, there's more than one way to do mathematics, so the way you're seeing here is not the only way. There's definitely other methods to get to the solution. But in my case, I started off by first breaking down all the terms, and I noticed that the 3 was repeating in all my 4 terms. So I used the GCF method to start off the problem, and I took out the 3 that was repeating in all of the 4 terms, and I wrote it in front of the bracket. Then I wrote the leftovers inside the brackets, and I added an extra 1 and a 1 in place of the 3's that were there. So the 3 turns out to be 1 and a 1, just so that on the next step I can see that there's common factors. So on the next step, I looked at the first 2 terms and I asked what's common there. It turns out that the x cubed is common, and the leftovers are x squared minus 9. Next, I took a look at the negative 1 x squared and the 9, and I looked at what's common. There's nothing in common except maybe the 1, if you want to write that. And also the first term in the list is negative, so I also factored the negative sign out. So that's how I'm getting the negative 1 on the 3rd line. So once I did that, I took a look at what's inside the bracket, and I noticed that the x squared minus 9 was repeating. So therefore, it needs to be written first. Then the x cubed and the 1 get together inside the second parentheses. Now x squared minus 9 itself is a difference of squares, so it can be broken down into x minus 3, x plus 3. And x cubed minus 1 is one of those SOAP problems. So I broke it down into x minus 1 times x squared plus 1x plus 1. And that's how the problem ends. So your strategy may have been a little bit different, but at the end of the day, if you got the same answer in no matter what order, doesn't have to be the same order as mine or not, as long as you have the same parentheses, the same 3 in front, then your solution is also correct.